Okay, Science 30, I'm just going to wait till this comes into focus. I'm going to finish up the acid-base section of this unit, and we're going to look at measuring pH qualitatively using acid-base indicators. Those of you who've been in Chemistry 30 and Chem 20, you know how this works. But on page 12, okay, you guys have all of your acid-base indicators. And what this shows is where they change color in different ranges, okay? So you can see that methyl violet at a pH of 0 or below is yellow. If methyl violet is in a solution that has a pH of 1.6 or over, it would be blue. But for example, if I see methyl violet again, and let's say the pH range is somewhere around 1, you would see the indicator change from yellow to blue, so it would be like a green color. Thymol blue has 2 endpoints, but you can see if thymol blue is in a pH of 1.2 to 2.8, you can see red to yellow. So let's say the pH is around 2 in that solution, the indicator itself would look orange. So these guys all change color at different pHs. So below their low level, it's the color on the left. And above or close to their pH range on the right, it's the color on the right and above, right? So you can see chlorophenol red would be yellow in a pH of 5.2 or below, or close to 5.2. Chlorophenol red with a pH of 6.8 would be red, or close to red, in a pH close to 6.8. Okay, so you have acid-base indicator chart also on page 184 of your textbook. There's a practice example for how you measure the pH range as well on page 185. So you can sort of walk through that example. If you need more supplementary information, you can see the info on your data booklet here. But anyway, I'm going to do a couple examples. Okay, and I'm going to look at number 27. Okay, and I'm actually going to do a pH range for this. So this is something you have to do. You have to do a pH map, and this is indicating pH qualitatively. So not using numbers, so we're not calculating values. We are estimating values with the indicator. So we're not getting exact pH values. We're getting a range, and then we can get more specific from there if we do further experimentation. So number 27 says a solution is tested with 3 indicators. Here are the results. Okay, so litmus turned red. So if I look at number 27 on page 186. Okay, litmus is red. We should already know that this is an acid because acids turn litmus paper red. But let's go through the rest of it. Thymol blue. Thymol blue is orange. Okay, so here's what we have for thymol blue. Okay, so from 1.2 to 2.8. So we know that it was orange, so we know that the indicator must be somewhere in here. And then when I look at orange 4, which is the other one, so it's orange for thymol blue, and then orange 4. Orange 4 is red. Okay, so I know from 1 point, right, so I know that from 1.4 0.8. So this is red to yellow, and this is 2.8. Okay, so this is going to be about 2. All right, and then this is yellow. Sorry, this is red, and this is yellow. Okay, so I know that it's red, so I know that it's acidic. Now we're just determining the range. So it's red, so I know that it has to be around 1.4, but my thymol blue indicator gives me an orange, so I know it's between 1.2 and 2.8. So what I can do is I can make this pH range here. And I know that my pH range is probably, it's likely between 1.4 and 2.0. So that's going to be my pH range, and that's how we use indicators in order to solve for these types of things. Okay, so let's look at another question. Page 187 has a lot of good sample problems. But if we look at number 28, it says a few drops of bromocresol green and a few drops of thymol blue are added to the same solution with a pH of 5.6. What color do you expect this solution to be? So bromocresol green, 3.8 to 5.4. The pH is 5.6. So I would expect the bromocresol green to be blue. If we had two different little spot plates with the same solution, we would expect bromocresol green to turn blue. And then if we have thymol blue, there's a pH of 5.6. Okay, so 1.2 to 2.8. And so between 2.8 and 8, this thing's yellow. So I should expect my indicator to be yellow with the thymol blue and green with the bromocresol green. Okay. So again, look at this example here. So bromothymol blue on page 185. Bromothymol blue so this solution, bromothymol blue is blue, phenolphthalein is colorless, phenol red is red. So if we look at the pH ranges, 6 to 7.6 blue, around 7.6 bromothymol blue will be blue. If I look at phenolphthalein, anything below 8.2 is colorless. Okay, and then phenol red, anything above 8 is red. So if I look at my values, and I have the pH ranges of them all together, I will be able to decipher that the pH of the solution is between 8 and 8.2. So I don't get exact numbers, but I get a range. Okay. So that phenolphthalein being colorless really tells us a lot, because phenol red and bromothymol blue overlap. Okay, so that's how you determine pH qualitatively. All right. Now the last part of this unit, of this portion of the unit, looks at how do we clean up acid precipitation. All right. And I've already mentioned buffers. So buffers can get rid of hydronium, right? Because the buffers can accept the hydrogen and take it out of solution and therefore take it out of the environment. So we have the same sort of deal in our body. So take a look at the carbonic acid buffering explanation in my notes, okay? So basically what happens with carbonic acid buffering is, as a result of cellular respiration, right, we make an excess of carbon dioxide, and that gets blown off into our bloodstream, and that turns into carbonic acid. So read through these. So the carbonic acid itself, when the CO2 is blown off from our cells, the carbonic acid makes hydrogen carbonate and hydrogen ion. Now the hydrogen ion itself will bond to our red blood cells, and then we can take that to our lungs and get rid of it. This HCO3 negative is a base, and if you remember that from your acid-base chart, you'll see that the hydrogen carbonate ion can be a base or an acid. So we can get rid of this hydrogen by converting the CO2 into H2CO3 by reacting it with water in our bloodstream. And then the H2CO3 breaks up into hydrogen carbonate, which is a buffer or a base that can neutralize the acidity of our bloodstream. And the H plus is attached to hemoglobin in the red blood cells, and that gets sent to our lungs and then let go. And then so that's what all this talks about here. So there's some more diagrams about carbonic acid buffering. If you're in Chem 30, you guys have seen this, and you've seen this in Bio 20 as well. Okay, so how do we reduce and mitigate acid deposition? Well, really it's about either reducing our fossil fuel emissions or cleaning our fossil fuel emissions, right? So things like removing a catalytic converter from the exhaust of your truck is not a way that you get rid of sulfur and nitrogen oxides, and those contribute to smog and acid precipitation, right? So we're phasing out coal in Alberta, but one thing that we can do with coal, right? We have coal gasification plants. We can turn coal into natural gas, and that's a much cleaner fuel because we get rid of all the extra carbon. So coal-fired power plants are, even though we're phasing them out, they're still used, and that's because we have lots of cheap and plentiful coal. Now, coal creates this really fine carbon called fly ash. So on our smokestacks, rather than just having that end up in the atmosphere, right? So you can see this is a power plant where we burn the coal, and that heats water, and that water heating and cooling turns a turbine in the presence of an electromagnet, and that makes electricity. That's how all power plants work. We're going to talk about that in a later unit. All right? But we can do a couple things with fly ash. So we can get rid of the fly ash through something called a scrubber. So on the smokestacks, we'll have this unit here, and it's basically an electric current that moves through the top of the smokestack. And there's a mist or fluid that's released within the smokestack. So think about after a rainstorm on a summer day in Calgary. Like it's a hazy day and the air quality is bad, and then you have a thunder and lightning storm, and then that electricity in the water cleans all that particulate out because it bonds with the water and it bonds with the electrical current, and all that particulate ends up on the ground after. So basically what we do inside a smokestack is kind of make it rain inside there. And this is actually how a catalytic converter works as well. You have electric currents that move through the platinum converter, and then impurities bond to that as a result. So you can see, so look at this in my notes, right? So the smoke particles become charged, and then they're attracted to the positive terminal, and they don't end up outside being released into the atmosphere. So this is a scrubber. So a scrubber could use that electrostatic guard as well, but you could also, when sulfur and nitrogen leaves through a smokestack, you can do the same thing that rain does. So the rain here, basically inside the smokestack, will clear out the sulfur and the nitrogen, and they're acidic, so that if they combine with a cation, then we can remove that slurry. And that's another way that we purify industrial waste. So again, that's what a catalytic converter does in your car. So it's like a scrubber on a small scale. All right? It's really irresponsible to not have a catalytic converter, because this is the result, right? So this is smog, and it's a huge health problem. So, right, you can see that is, this is, what city is this? This is Kuala Lumpur in Southeast Asia, and you can see the air quality. So that orange haze actually comes from sunlight reacting with nitrogen oxides in the atmosphere. So photochemical smog is the brownish red haze. Exhaust from fossil fuels creates the nitrogen. And then this actually creates another ozone layer right close to right close to the surface of the Earth. Now the ozone layer way high up in the stratosphere is great for us because it keeps ultraviolet radiation from getting to the surface of the Earth, but close to the surface of the Earth, it's terrible for us because it keeps these toxic chemicals close to us. It's called an inversion layer, and this is really bad for our health. So you don't need to memorize this, but what you should understand with smog, so this is another form of chlorosis. So you can see that these are smog-affected plants. So they've had acid precipitation follow them, and you're now seeing chlorosis. So you have the nitrogen and the oxygen that is bonded in your internal combustion engine because there's a lot of heat, right? And then once that's expired, it reacts in the atmosphere to make NO2, and then that can combine with water in clouds and make nitric acid, right? And then we get this ozone as well. So this is Los Angeles. Okay. And like I said, you get another ozone layer, and the ozone is a very potent lung irritant if it's close to the surface of the Earth. Okay. So we want to have clean emissions. Also, from fossil fuel burning, we get VOCs, right? So when we burn things like tires and all that, right, there's large hydrocarbons, and those things get into the atmosphere. But we also have lots of industrial chemicals that if we burn, there's byproducts of fossil fuel production. They will get into the atmosphere and also cause issues. Like CFCs are a great example. Refrigerants, they put a hole in the ozone layer. They can also get into our lungs. So vaping has a lot of these types of solvents that are causing popcorn lung, right? So the same chemicals that we get from industrial processes are being concentrated in your lungs by vaping. So we need to clean up how much we use fossil fuels. Now we obviously need fossil fuels, but it has been something that has been needed to be mitigated for a long time, and we need some long-term solutions. So hopefully you guys can come up with a few as you go throughout your life. Anyway, that's the end of the first part of this unit. I'm actually going to post your quiz for this unit part, this first part of the unit, the acid-base section. So the science acid-base quiz will be available for you, and you can do this at your leisure. It will be due probably next Friday. So anyway, keep the questions coming, get your stuff done. These are all the lectures that you guys need for Science 30 today. All right, bye now.